Welcome back to Enchanted Learning. It's me Benasar Khalid. So here once again welcome to the NCRT series. So are you preparing well for the CTET examination? If so, it's good. If not, you have to do it as soon as possible. So we were discussing certain chapters that's mentioned in Standard 6, which are very important or very useful for the particular examination. And we are discussing NCRT syllabus of new version. So we have discussed 3 chapters of Standard 6. Now we are moving to the 4th chapter, that is exploring magnets. Here we are going to study about magnets and its properties, etc. So let's move to the chapter. Here first we have to understand, here different varieties of magnets are shown, different shapes, magnets of different shapes are shown here. Before that, it's mentioned here, we now search for information on internet and school library, etc. But before that, the travelers used a particular device to find directions, and that device was known as magnetic compass. You have already heard of it. So the travelers use this magnetic compass to find those directions. So magnetic compass. Here we have to understand what is magnetic compass, what is magnet, etc. in this chapter. So first, you have to know there are certain naturally occurring magnets. They are known as lodestones and they were discovered in ancient times. Later on, people found out that magnets can be also made from pieces of iron. So that the magnets are made up of different materials. So first, naturally occurring magnets were also there. Later, magnets can be made, or can be made from different materials. It means it can be made from pieces of iron, etc. Discoveries led to the formation of magnets from different materials. So here magnets of 3 shapes or different types of magnets are there. Here 3 shapes are mentioned, which means bar magnet, U-shaped magnet, ring magnet, etc. So what is the difference between a magnetic and non-magnetic material? How can you identify those materials which can be attracted by magnet or not? For example, take in the case of pencil. Pencil is made of a material that is means of wood. So whether it can be attracted by a magnet, to this particular experiment, you can understand that the material is made up of, the particular object is made up of wood. So wood, it cannot be attracted by a magnet. Then in case of eraser means rubber. It is also made up of another material, that is rubber. So it can be attracted by magnet. If the magnet say near to that particular rubber, will it be attracted? No, that is also not attracted by magnet. So he can take an iron nail and place a magnet near to it. Whether it gets attracted to the particular magnet? Yes. That means here plastic, wood, glass, etc. are not attracted by magnet, whereas iron and all other certain materials are attracted by magnet. So that from here, we can understand that all materials are not attracted by magnet, and those materials which are attracted and stuck to the particular magnet are called magnetic materials. Means in case of iron nails, when you place a magnet near this iron nail, what happens to the iron nail? These iron nails get attracted or stuck to this magnet. That means the iron nail is a magnetic material. It can get attracted to magnets. That is, materials which are attracted towards magnet are called magnetic materials. So that is for the first term you have to note it, that is magnetic materials. Magnetic, those which are attracted towards magnet. Next one, for example, this metal iron is a magnetic material. Metal iron is a magnetic material. Next point, what are non-magnetic materials? Those which are not attracted towards magnets are called non-magnetic materials. So, metal is an example for magnetic material, whereas nickel and cobalt or also other materials that are also magnetic. So, iron, nickel and cobalt. These are examples for magnetic materials. And those which are not attract towards magnets are called non-magnetic materials. It can be of plastic, wood, etc. So, materials can be of two types, that is magnetic materials and non-magnetic materials, where those attracted to magnets are called magnetic materials and those which are not attracted to magnets are called non-magnetic materials. So, it's clear for you? Yes. Now, moving to the next one. If you, that's an experiment. Listen here. You have to take a bar magnet. This is a bar magnet, no? Let's assume this as a bar magnet. This is a bar magnet that spread some iron fillings on a sheet of paper. You have to spread some iron fillings on a sheet of paper and place a bar magnet near it. What happens? Then tap the paper and observe carefully. You have to spread some iron nails on a iron fillings on a paper, then place a bar magnet over them, then tap the paper. What happens to iron fillings? You can see that the iron fillings stick to the magnet. The iron fillings stick to the magnet. So it sticks to the magnet. Here you can understand one thing. Thus, these iron fillings sticks more to the poles of the magnet. Is it? Iron filling sticks more to the poles of the magnet. You can find maximum iron fillings are seen or stick near the ends of the bar magnet, and these ends are termed as the poles of magnet. So the end of the magnets are called the poles of the magnet, and that is the north pole and the south pole. So by doing this experiment, we have analyzed the fact, we have understand the fact what the magnets have two poles, that is north pole and south pole. How can you distinguish it? That means always the magnets will be remaining north, that is north and south, or always the magnets have a north pole and a south pole. So here you must understand the first fact, that is most of the iron fillings stick to the poles of the magnet of any shape. So let the magnets be of any shape, the iron fillings stick to the poles of the particular magnet. So it is possible, it is if you are breaking that particular magnet into smaller pieces also, then also smaller pieces, then also what happens, this north and south pole always exist in pairs even in the smallest piece of magnet. So we cannot obtain a magnet with a single pole. That is, if you are breaking a particular magnet, it can be of many pieces. Even then, it exists in pairs. Its pole exists in pairs. That is, it poles in pairs. That is north and south pole. It is not possible to obtain a magnet with a single pole. So that is a major point we have to understand here. That is, most of the iron fillings stick to the poles of the magnet of any shape. And second point is that the magnet, if it is broken into small pieces, north and south poles always exist in pairs, even in the smallest piece of magnet. Next, moving to the next point. Here, it's a particular activity done to find out the direction of the magnet. Suspend a bar magnet with a thread tied to the middle of the magnet, and let's you have to need to adjust the positional string to the magnet's balance horizontally. That is, you have to suspend a bar magnet which is with a thread tied to the middle of the magnet. A thread is tied to the middle of the magnet and suspend the bar magnet like this. And place it like that. Now rotate the magnet gently in the horizontal direction. Let it come to rest. So after that also, the magnets rest along the same line. Here we can see that after rotating also, the magnet comes to rest in the same, that is in same position. That means the magnet always, when a magnet is suspended, a freely suspended magnet comes to rest along the north-south direction. So, first next point you have to understand or recall is, a freely suspended magnet comes to rest along the north-south direction. So, a freely suspended magnet comes to rest in north-south direction. So that is the direction of magnet. So a freely suspended magnet comes to rest along the north-south direction. That means the end of the magnet that points towards north direction is called the north-seeking pole or the north pole. So the end of the magnet it points to north direction. You understood the fact that magnets consist of or exist in, or it always exists in two poles, and that pole that is corresponding to the north direction, to it seen towards a north direction, is called the north seeking pole or the north pole of the particular magnet. And the other point that's facing toward the south direction is called the south pole of the magnet or south seeking pole of the magnet. This north pole and south pole. So that is how can we identify the direction of poles of a magnet. That is, a freely suspended magnets always rest in north-south direction, and the pole that is facing towards the north direction is known as north-seeking pole or north pole, and the face where which is that is the pole, the end which points towards the south is known as the south-seeking direction or south pole of the particular magnet. So you have to understand the point, the only point, that is a freely suspended magnet comes to rest along the north-south direction. And a freely suspended magnet rests along the north-south direction because our earth itself behaves like a giant magnet. So it is also the one another fact, that is the freely suspended magnet comes to rest in north-south direction because our earth is also it's a giant magnet. It behaves like a giant magnet. So that's freely suspended magnet always rests in north-south direction. Now, next one. This property of this freely suspended magnet to always rest along the north-south direction is used to find directions. So the property of the particular magnet, that when the magnet is freely suspended magnet is allowed to rest, it always comes along the north-south direction, and this particular property of the magnet is utilized to find directions. And that particular property is utilized in a particular device called magnetic compass, and that was used in olden days to find directions. So, how can you identify the direction? The particular magnetic compass was used to identify this direction by the property of the particular property of that magnet. How can you identify the direction by using a magnetic compass? That is, a magnetic compass that it has a magnet in the shape of a needle. It has a magnet in the shape of a needle which it can rotate freely. And the needle of the magnetic compass indicates the direction of the north-south direction. So, the compass needle consists of the magnetic compass consists of a needle, and that needle is made up of magnet, and that magnet so indicates the north-south direction. That likewise we can find the direction of particular. We can find out the direction. So the compass is kept at place where you wish to know the directions. At the same time, the needle always comes in northwest, come to rest in north-south direction. Always the compass needle comes to rest in north-south direction because it is a magnet. And that property of the magnet is utilized in magnetic compass to know directions. That is what mentioned in the particular topic. Next, moving to the next one. Now, what happens when two magnets come closer? Here we are going to study about the attraction repulsion between magnets. So what happens when a pair of bar magnets, that is on which north and south poles are marked. So if you have to take two bar magnets where north and south poles are marked, and you have to mark north and south pole, then place a longer side of the magnet A over 5 to 6 round sheet pencils. Now bring one of the magnet B near the end of the magnet A placed on pencils. So by doing the particular activity, we came to the conclusion that the poles of the magnet. So here when two bar magnets are kept closer, what happens to its pole? What happens to the pole of these particular magnets? Here you can see, here this pole is south and the particular pole of this magnet is north. So this is north pole and this is south pole. As these two poles are unlike poles. These are different poles. They are unlike poles. What happens? There is one is the north pole of one magnet and other is the south pole of another magnet. What happens? These poles get attracted to each other. That is, here these poles are unlike poles. They are unlike. They are not similar. So unlike poles attracts each other. Unlike poles attracts. Then what happens to the other one? If here we are placing another magnet, A magnet is placed as like this. You can see that these two poles are similar. So they are like poles. Here what happens to like poles? Like poles repels each other. So like poles repels each other where unlike poles attracts each other. Here like poles they repels each other. So that is another fact we have to understand. So first one, we understood that a freely suspended magnet always rests in north-south direction, and the compass needle is another device which makes use of this property of this magnet. And here in the compass, magnetic compass, a particular needle is made of magnet, and that seems to show this property of this magnet. That is, when it's freely suspended, it always remains in north. It always rests in north-south direction. Then another point we have to understand that here when two magnets are kept closer, what happens if the like poles are kept closer? Then what happens? The like poles repel each other. And when two similar poles are, that is similar poles, like poles, they repel each other. Whereas if there are two different poles, it's unlike poles, they seek to attract each other. So another fact is that like poles, that is either north pole or south pole, they repels, whereas the south pole and north pole attracts each other. Unlike poles attracts each other. So in the next activity, the magnetic compass and a bar magnet is kept closer. Then what happens? Is there any deflections in the compass needle or within the magnetic compass? If this compass needle deflects and moves away from the particular bar magnet, then you have to understand that the pole of the bar magnet and the pole of the particular magnet needle will be same. So unlike poles repels each other. When a particular bar magnet is kept closer to a magnetic compass, then if the magnetic needle comes closer to the bar magnet, you can assume that you can find out that the pole of the bar magnet and the pole of the magnetic needle are different. That is, like poles repels each other, whereas unlike poles attract each other. That means the north pole, when the north pole of the magnetic bar magnet is brought closer to the north pole of the compass needle, it moves away. Similar, north pole, so it repels each other. When the south pole of the magnet is brought closer to the north pole of the compass needle, that is north pole and south pole, then it moves closer. That is what mentioned here. Then in the next experiment, you have to place a piece of wood in between a bar magnet and a compass needle. If the same experiment is done, that is if the compass needle is deflected towards the bar magnet and seems to be deflected towards the bar magnet, that means here unlike poles attracts each other. So if it is in that position, in between this piece of wood or plastic or cardboard is kept, what happens to deflection of the particular magnetic compass? That is, the magnetic deflection remains the same. That means that from here we can conclude that if you are taking any particular sheet of wood, cardboard, plastic, glass, etc. in between the bar magnet and the compass needle, the magnetic compass, there show no appreciable change in deflection of needle. That means the magnetic, if any material is placed in between the magnetic compass needle, there no appreciable change can be seen in the deflection of needle. We can conclude the fact that the magnet effect can act through non-magnetic materials. That is, when a bar magnet and a compass needle and a magnetic compass is placed, and if a piece of wood or plastic or cardboard is placed in between the bar magnet and the magnetic compass, what happens if the deflection of the magnet remains the same, magnetic needle remains the same, or if it is deflected towards the same direction as it kept before, that means you can understand that this magnetic effect, you can conclude that the magnetic effect can act through non-magnetic materials. That is, if it is deflected towards, before keeping that wood or plastic or cardboard in between them, if the magnetic needle is deflected towards the magnet and it remains same as if when we introducing a wood or piece of plastic in between them also, the same situation is repeated, then you can conclude that The magnetic effect can act through non-magnetic materials. That is what mentioned here. So that's all about, and that's all mentioned in this particular chapter. So here we understood what are the facts we have studied. We study different types of magnets, magnets of different shapes. We study the property of magnets, and we also many facts related to magnets. Is it clear for you? So that's what mentioned here. That means one of the, what is a summary here? A magnet has two poles, it means a north pole and the south pole. And second one, the magnet always, if a magnet is suspended, it comes to rest in a north-south direction. And you have to also understand the magnet materials are materials that are attracted towards a magnet. And those which are not attracted towards a magnet are said to be non-magnetic materials. And the needle of compass, magnetic compass, seems to be a magnet itself, and it always indicates a north-south direction. And when two magnets are kept to each other, if the same poles are kept, like poles are kept closer, then it repels, whereas the unlike poles attracts each other. For example, one question, there is unlike poles of two magnets dash each other, whereas like poles dash each other. So, unlike poles of two magnets attract each other, whereas like poles repels each other. The materials that are attract towards a magnet are called magnetic materials. And the needle of a magnet compass rests always along the north-south direction. A magnet has two poles, mainly north pole and south pole. Next one, you have to state whether the following statements are true or false. That is, a magnet can be broken into pieces to obtain a single pole. Is it true? No. That is, even after breaking into a number of pieces, the magnet seems to have existing with the two poles. That is wrong. Similar poles of magnets repel each other. Is it right? Yes. That is, unlike poles repels each other. Iron fillings mostly stick in the middle of a bar magnet which is brought near them. So, while conducting activity, that when iron fillings, what you have seen in the case of iron fillings and a bar magnet, you can see that iron fillings stick mostly where between in the poles of the within the poles. The iron fillings stick mostly towards the poles of the bar magnet, and very few fillings are stick to the middle of the bar magnet. So this statement is wrong. Iron fillings mostly stick within the poles of the bar magnet which is brought near them. Then a freely suspended bar magnet always aligns with north-south direction. That is wrong, right. A freely suspended bar magnet always aligns with north-south direction. Next one, here what indicates the attraction or repulsion. That is north and north. North and north means that is like poles. They repels each other. The north and south pole, what happens to it? Attraction. Then south and north pole, here also attraction. Then south and south pole, what happens? Repulsion. That is here. Now, if you are, an experiment is done here, where bar magnet is kept and a heap of steel U-clips are kept. If the steel U-clips are kept near a bar magnet, like in the case of iron fillings, what number of pins attract the magnets at various positions. So first position A, 10, let it be 10. Position B, let it be 2. Position C, let it be 10. And the second is, like position A. So that's all about exploring magnets. So you have to keep up these points in your mind, and that questions may be asked in relation to these points. So while studying, keep all these things in your mind. If this class is found to be useful, please subscribe my channel. Let's see you in the next class. Till it's bye from me. Thank you.